Hi, this video we're gonna look at a force that's in 3 dimensions. For example, as you can see here, there's a force F in the direction from O to A, and we're going to decompose this to X and Y, Z component. So our goal is trying to get Fx, Fy, and Fz, right? We'll decompose them to those three dimensions. How do we do so? So first is method 1. Method 1 is actually not quite often used, but it's good to illustrate it. So they give us the angle theta y, that's between the force and the y-axis. Then they did the first projection. So F is going to be projected to y-axis. Of course, we're going to get Fy, right? That's how we get decomposed, the projection to y-axis. And then we also projected to this horizontal plane. That's why it's labeled as FH. H means horizontal plane, this XZ plane. Okay, then we had that, and then we understand Fy will be F times cosine theta because it's adjacent to this angle in terms Fy. And also we're gonna get a projection FH here. That's gonna be this is theta y, so we'll get sine theta y. However, the story is not over, right? Because we got Fy now. However, we need to get Fx and Fz. In order to do that, we're going to do our second projection, Fh, that decomposed to x component and y component. In order to do so, we need to have another angle. So the angle here is this side here, this angle here. And so this side is basically the Fh, the angle between Fh and the x-axis. And again, remember FH? FH is the projection of this force projected to the bottom plane. So knowing that, we can do our second projection. So Fx is going to be our Fh times cosine theta. Why? Because this is 90 degrees. And then Fz, and this is again 90 degrees, so will be Fh times sine psi, and then we substitute our Fh in here. From this first projection, we get our all three x component. Okay, so in order to do this, we needed to know the force F, right? We also needed to know the angle theta y. We also needed to know the angle psi here. So now we're gonna get into the most universal method. It's right here. Now let's look at this force again. This OA force F. F is going to be projected to Fx, Fy, Fz, and then they projected to this cube. Now, if we're going to looking at this triangle here, OAD. So if OAD, this triangle, if I were to tell you this OAD, actually this angle here, D, is 90 degrees, will you believe me? Doesn't look like a 90 degree, right? By just looking at it, it doesn't. So here I'm trying to convince you that is indeed a 90 degree angle. If you can actually visualize it, great. So, but here is some kind of tool that helped me convince myself it is 90 degree. So let's go back to this one, perpendicular plane. So if I have a line, line L here, that is perpendicular to this plane A. And then on this plane A, there are many rays coming out. And I will say this line is going to be perpendicular to all those orange lines. Do you agree with me on that, right? If that is true, then we're gonna think about this scenario. We're gonna see this angle A is 90 degrees. How do we believe that? Now let's think about, is this OD, right? Is this OD, this line, is this OD perpendicular to the side plane, the right plane? Yeah, they are, because it's a cube. So OD is right here. It's going to be perpendicular to that right side plane. If that is the case, if then OD, this line, is going to be perpendicular to any line, like what we have over here, this orange line, any line that's on the plane, so which is AD. So here, from that, we say OD is going to be perpendicular to AD. So that's a 90 degree. Okay. So knowing that, we can come back to believe this OAD triangle here is 90 degree. It's right triangle. So since this is 90 degree, then OF is going to be your hypotenuse, right? Opposite of to 90 degrees. So if I were trying to draw this, and we said D is going to be the right triangle if O is here and A is here. OA here is our force, and the force, and there's an angle theta x. Angle theta x, that is the angle between the force F and the x-axis. So that's our theta x. Now we are going to try to find OD because that's the Fx. Then knowing that, we know it's going to be cosine theta because it's adjacent. So we have F equal to Fx equal to F times cosine theta. Okay. Then we got our Fx component. Now we are going to continue to look at other projection, and hopefully we're going to get another right triangles as well. And for example, here in this sketch here, we have this green triangle that is OAB. And this is the force we decompose, OF, and Fy is what you're solving right here. And the angle, theta y, it is the angle between the force and the y-axis. Just like theta x, it's the angle between the force and x-axis. Okay. So if I were telling you there's a right triangle, hopefully you kind of believe now that's going to be this triangle. This is going to be the right triangle. Another quick thing to know which angle is right triangle, here's a trick. So you see the force here, OF, that what you have decomposed, the angle that's opposite to this force you are decomposing, that's going to be 90 degree. Okay, let me clarify that again. For example, here. OF, that's the force you decompose, and the angle that's opposite to this force right here, D, that's going to be 90 degree. All right, hopefully that will make things way easier, right? So if that's 90 degree, we can do the same thing if we want to demonstrate that triangle. So we'll have this, and remember B is going to be 90 degree right here. So that's going to be B, and we have OA. This is going to be force you decompose. That's opposite to this 90 degree. And OB, it's Fy, so we're solving Fy. And the angle between the force and y-axis, that's going to be a theta y. So similar thing, we're going to F times cosine theta y, that's going to be our Fy. Okay. So look at the last cube right here, and I believe you already completely convinced this triangle OAE, that's going to be a right triangle. Using our quick trick, the angle opposite to this force, that's going to be 90 degrees. So if that's a 90 degree, and we're trying to find FZ component, which is right here, that's opposite the angle we have to give. The angle theta z, it's between the force you're decomposing to the z-axis. The axis is pointing forward to us. And so that's theta z. And if I were to draw that in 2D, we know this angle is going to be E. This is 90 degree right here. So that would be our E. And if we do, that's going to be OA. That's the force you're decomposing. It's opposite to this triangle. OE is your FZ. And the angle between z-axis and the force, that's your theta z. So you just kind of like move that triangle from three-dimensional space, move up to look at the plane in 2D. Then you know theta z is going to be equal to F times cosine theta z. Okay, so those are very important information. That is our general method to decompose the force that's in 3D to fx and fyz. And they all take the same form, f times cosine. And the angle, so theta x is going to be the angle between the force and x-axis. So that's it. And theta y will be the angle between force and the y-axis. All right, knowing that we have achieved our goal, we have decomposed our forces in 3D, and if we were trying to write in a 3D vector form, we're going to add our ijk, our unit vector, right? I is a unit vector for x-axis, j is y for y, and k is a unit vector for z-axis. Since you already know fx, fy, and fz, you can just go ahead and write in this form. And then expand, we have this one here. F is equal to f times cosine theta, that gives us fx. And f times cosine theta y, that's going to give us fy. And f times cosine theta z, that's our fz. So from here, we got this equation. Okay, so this is exactly what we just did, right? So we just did that, and now we are going to introduce this concept called lambda. Lambda is also a unit vector. Unit vector only means the magnitude is 1. Magnitude is 1. That means, you know, the length is gonna be 1. Then let's go look at this one. If this is lambda, it's gonna be our unit vector, and we think about how do we get to magnitude. Let's do a quick review. In 2D, if you find fx, which we did one time, and we also find fy. If you know those two, how do you find the magnitude of the force? And remember, in the 2D resultant topic, we said if you find fx and you find fy, and we're going to find the resultant. How do we do it? That's our resultant. We use Pythagorean theorem. We said the magnitude of this 2D resultant is going to be summation of all the fx squared plus summation of the fy squared, right? Knowing that, we are going to borrow the same concept from 2D to 3D. So if it's a 3-dimensional like where we are now, then for this force here, what's the magnitude? The magnitude is going to be fx squared plus fy squared, then plus fz squared, and take a square root, because we're going to do actually Pythagorean twice. Then we talk about this unit vector, and unit vector, which means the magnitude is 1. If it is 1, this is going to be this term squared plus this term squared plus this term squared is going to be equal to 1. So that's going to be an important equation that help us solve some problems. For example, if you know two angles, you know theta x and theta y, can we use this relationship to find our theta z? Certainly we can, right? So those are, we are borrowing this unit vector with magnitude as 1 concept. Then here's another form for cosine theta x. Since fx, we're talking about x component is equal to f times cosine theta x. Certainly we can manipulate, say, cosine theta x is going to be fx over fy. So that's all the concept in terms of decompose a force in 3D. A quick wrap up, those are the important equation I'm going to highlight. First one, the decompose and understand why, how do we get this. And once we know that, we're going to write in a 3D form, 3D vector form, fx, fy, fz, and we know that, so we can actually go ahead and plug it in here. Once we have this equation, we come up this unit vector. So then we can write down f is equal to f lambda, right? And with this unit vector, we have this relationship, and we figured out how to figure out the magnitude of force in 3D, Pythagorean theorem. And then there's a relationship to finding the angle using fx over f, and that's cosine theta x. That's all for this one. I'll see you at next. Bye.